G'day. We're down on the floor today here because we're going to look at this beastie here today. A big part of the reason that we're looking at it is because my other projects fell through. Up there I've got a UltraSpark 5 and I was hoping to get it working to show you, but sadly I wasn't able to build enough packages for it in NetBSD. And that's part of the reason we've got this beastie out. This is a Sun V440. It's the most powerful Sun enterprise server machine that I have. This beastie has 4 1GHz processors and about 10 gig of RAM. So that makes it ideal for building packages for operating systems like NetBSD, but probably also stuff like Solaris and that kind of thing too. So today what we're going to do is I'll show you some of the internal hardware. We'll talk about how its performance compared, maybe do a little bit of benchmarking if I can figure something out, and we'll look at some software running on it. Although I haven't got much of that because obviously it needs to run on quite an esoteric machine. Let's take a look.
Sun made these machines with maintenance in mind. If you open it up and take a look inside, you'll find basically a pile of modules that can be pulled out of a back plane. The 4 large modules on the opposite side of the machine there are the CPU modules, which also contain the system RAM. The empty space close to us is where all the PCI cards go. You can see the advanced lights out management card, but behind the chassis there is also a 1 gigabit network card. Fortunately, I have some spare parts we can look at without having to take this one apart. Here I have a CPU module. This one is actually faster than the ones I have installed in the machine. It's actually a 1.6 GHz. I don't have enough to populate a full machine, so I've stuck with the 1 GHz here. Notice it also has all of the memory installed. This is DDR1 2100 ECC RAM. The Sunfire V440 features hot pluggable, redundant power supplies. The system only needs one to remain up, so you can remove one if it fails. Rather than using the onboard NIC, I've added this 1 gigabit Ethernet card. You'll notice that it's a 64-bit PCI card that could fit into a 32-bit slot. This machine has 64-bit PCI slots, so we get the full benefit out of this card. If we come around to the front, you can see 4 slots where hard drives can be placed. The machine supports 4 Ultra 320 SCSI hard drives. I happen to have 2 HP 10K drives in the 2 upper slots, and in the bottom slot I've got an IBM drive that just so happens to have a Sun label on it. I'm very lucky to have quite a few SCSI hard drives of this nature spare, so I don't have to worry about any of them failing. But I do have a shortage of these trays that fit the drives into the slots. They are much harder to find. Hardware like this does not have a display or keyboard, so if you want to look at the console messages or install an operating system, you'll need to connect to it via serial. This cable here is what I generally use, along with a null modem cable and a gender adapter. If you have everything set up correctly, you'll get console messages over the serial port. In my case, I've got the diagnostic power on self-test enabled, so here you can see quite a lot of testing to make sure the machine is working correctly. You would normally run the machine with this diagnostic turned off, as it takes roughly about 20 minutes, but I've found that it's useful for me to run it every time I get the machine out of storage, because sometimes a memory stick or something like that has failed and needs replacing. Before we look at the benchmark results, let's take a look at some UltraSpark chips and the contemporary competition from Intel. These chips are from before when the V440 was released. On the right we have the UltraSpark 3 CU. Its clock speed may have been lower, but like the PowerPC, it had better IPC than Intel chips of the time. So its single-threaded performance here is not quite as good as the Intel part, but almost there. I also noted it has significantly more cache, with the level 2 cache being on a separate die. I have a machine with this CPU in it, the Sunfire 280R. On the left is the Intel Xeon Foster, which was based on the Pentium 4 CPU. While it is faster for single-threaded tasks, the Sunfire excelled at multi-threading. This would probably be due to the difference in the operating systems these computers ran. Moving to the next generation of chips once again, the Intel Xeon outperforms in single-threaded tasks, but the UltraSpark retained its advantage in multi-threading. This is the V440 processor on the right. Intel released another chip in 2003, which really tipped the scales in their favour. The Intel Xeon Gallatin really tipped the balance towards Intel when it came to performance. I think it would have significantly outperformed the V440 in most metrics, including multi-threading. The only advantages left for the V440 were more hot pluggable components and integrated remote management. These would not last much longer. Of course, Sun had some higher level enterprise systems with significantly more CPUs, but these came with a much higher cost, so weren't really in the same market as these machines. I think this point really marks the tipping point where Sun's hardware was starting to really fall behind. They just didn't have the R&D budget to keep up with the big CPU vendors. Of course, I don't have any of those Xeon machines, so I can't do a reasonable benchmark against one. I picked my HP T620 thin client, partly because I already have NetBSD on it, but also because it is similar to the V440 I have in many ways. The main advantage the thin client has is much faster memory. It also shows how far technology progressed in 10 years, to the 2003 server class machine being comparable to a lowly thin client 10 years later. The difference in memory is exacerbated by the memory architecture of the two systems. The thin client is much like modern chips, with a single cache and a memory controller providing memory for all the cores. The V440, on the other hand, has its memory distributed across all of the CPU cores, each with their own memory controller. Accessing local memory is relatively fast, but accessing memory on another module incurs more latency, slowing things down. The V440 relies on the OS scheduler to make sure the CPUs access local memory more often to keep the impact of this latency down. This chart summarises some benchmarks I did. I tested heap sort, the sieve of Eratosthenes, Drystone 2 and Whetstone. In general, the UltraSpark did better than I thought, mostly suffering from the slow speed of its memory, when data doesn't fit in its cache. But when data does fit in its cache, it does quite well. I have some more detailed graphs. For smaller data sizes, the UltraSpark actually outperforms the thin client, despite being 500 MHz slower. There must be something about the thin client's cache that makes smaller datasets slower. There seems to be a sweet spot around 1 MB. We'll see this in some other tests as well. The speed decrease for both platforms is the result of the data exceeding the cache size. If you continued to test for much larger sizes, the results would tend towards the memory speed, where the thin client has a significant advantage. For the sieve of Eratosthenes, we get a similar trend. The UltraSpark carries itself well until the data gets bigger than its cache. Again, we see the small datasets running slower on the thin client. This time, the performance hits its peak sooner and lasts until the data is larger than the cache. I did both the single and double precision LinPack tests. These don't reveal all that much, but the thin client and UltraSpark scores roughly line up with their clock speeds. This test is rather odd in terms of its results. Flops is a C program meant to estimate how many floating point operations a CPU can do. It uses a small dataset and loop so that the instructions and data fit into caches. It seemed strange that it would measure the UltraSpark as this much faster, so I repeated the test multiple times. I got roughly the same results every time. It's likely this program is not a particularly good performance measure, although it does show the UltraSpark doing quite well here. Finally, I did a straightforward memory read and write speed test. The thin client's profile is fairly straightforward. The smallest buffers were slower, probably due to overhead, but it hit a peak at just around 12,000 megabytes per second in the level 1 cache. The The level 2 cache scored nearly 6,000 megabytes per second, and finally the RAM scored about 4,500 megabytes per second for reading, and 3,200 megabytes per second for writes. The UltraSpark has a different profile for reading and writing, most likely due to its NUMA memory architecture. The level 1 cache makes a big difference for reading, achieving around 8,400 megabytes per second, but it isn't much faster than the level 2 cache for writing. The level 2 cache actually writes data quicker at about 3,300 megabytes per second compared to 1,800 megabytes per second for reading. The memory installed in the UltraSpark is the weakest link in the chain, at around 300 megabytes per second. This is likely a product of memory latency and the test itself. The DDR memory really should be scoring something more like 2000 megabytes per second. Its architecture favours more parallel processing, as each CPU could theoretically use all the bandwidth of its local memory, provided the operating system organises things nicely. The thin client, on the other hand, has to share that bandwidth with all 4 cores. Because of this, it's possible that running Solaris instead of NetBSD would significantly improve the V440's performance. Okay, let's take a look at the V440 running some software. Obviously, because this machine doesn't have a display of its own, I'm having to use my own machine as an X terminal for it. I'm using Xming to connect to it. This of course means that some of the more action-packed software doesn't work quite as well as it would if the display was hosted locally, because obviously all of the display data has to go across the network. But as you'll see, it actually does surprisingly well. The first bit of software up here is actually DOSBox, and I've got it to play a few simple games like Bob's Fury here quite well. It doesn't do so well with more action-packed games though, so here we'll see it running Doom, and you'll see that it's not a particularly good frame rate. And here you'll see it's running Hocus Pocus, and whilst it's playable, it's a little bit janky, so DOSBox is not the best experience here. But I think it's reasonable for playing any game that doesn't involve scrolling. The next program I'm running here is called TK Gate, and it's a digital circuit simulator. This kind of program is really useful if you were building any kind of system with logic gates. It has the ability to simulate quite complicated systems. Now here I'm just using the tutorial just to show it at work, and I've got Doom running in the background just to show the multi-threading capability of this machine. The next bit of software here running is Kobo Deluxe, which actually really runs quite well considering it's running over a network connection. Now this system obviously doesn't have any sound because it's a server, so that is one thing that is missing from all the games we see here. Fortunately, I don't think Kobo Deluxe suffers from that too much. The next game here is a simple puzzle game called Fish Fillets. This one has you playing as 2 different sized fish, and your objective is basically to get off the screen. Now there's usually some obstacles in the way that prevent you from doing this, so you've got to use your abilities in pushing these objects to get them out of the way. This neat little animation here filled with bits of humour is basically the story for the game. The next game here is a Defender clone called Defend Gwyn, if that's how you say it. Anyhow, you're basically a little ship going around trying to shoot down Bill Gates, among other things, trying to save those penguins. Freedroid is basically a clone of the C64 game Paradroid. It works reasonably well with this X server, but I've actually found that if you make a virtual frame buffer on the machine and use X11 V and C, you get a bit better results with this game. The SDL version of FreeCiv basically plays perfectly on this machine. The only missing part obviously being sound, but yeah, with a game like this that doesn't matter too much. I was trying to get Rocks and Diamonds and another game, Mirror Magic, to work when I found this interesting game called Interlogic. It's kind of like a Sokoban game, but instead of pushing boxes into specific locations, your goal is to move the similar coloured spheres together, at which point they disappear. And of course you have to get every single sphere to disappear to make a level complete. It's a little bit tricky, but it was loads of fun. While I was still waiting for Rocks and Diamonds to fail to load, I found another game called Exploing. This is essentially your breakout clone. I did find it ran too fast the first time I got it to play, but a command line parameter slowed it down to a more reasonable pace. Moving on to a web browser. NetSurf works quite well on this machine, but of course without JavaScript, a lot of the modern web does not work very well at all, but those that do display reasonably well. The other web browser that I tried was Dillo, which also works reasonably well. It tends to display pages with reasonable formatting, although some of the characters like apostrophes appear weird. NetSurf and Dillo both format pages slightly differently, so I expect that some people would prefer Dillo and others would prefer NetSurf. The only thing against NetSurf is that it's slightly fussier when it comes to Xserver, so it can crash on occasion. If you need a more basic web browser to fall back on, Lynx is always there, and it works quite well even on much lower end hardware than this. Of course it is much more primitive when it comes to formatting though, so it's not as good an experience.
So that was the Sunfire V440. This interesting old beast is heavy, not very power efficient, and nowhere near as good at computing as something much newer. It's still quite interesting, but it's not something you'd use in its role that it was intended for. So this is the kind of machine I run in the winter, occasionally just for a bit of fun. It keeps my shed nice and warm when I'm out here, although it is a little bit noisy. I'm keeping it down here on the floor because it's pretty dang heavy, and lifting it up onto my bench is a little bit difficult, but there's also not enough space for it because the thing is massive. Anyhow, I hope you found today's video interesting. I'd like to thank you for watching, and I'll catch you next time. And now to extricate myself from this place on the floor. Jeez.